let's start now the mock interview. So you can give the brief introduction about yourself once.
Yes, I am Upalparna Datta and I am currently pursuing MTech in VLSI Design and Embedded System from IIIT Delhi, and my current CGPA is 7.19, and
Mhm.
I have completed my BTech in Electrical Engineering from Academy of Technology, where I get secured 9.15 CGPA, and now currently I have done some key projects like VLSI design in VLSI design and analog design, like RTL to GDS for pin protected locker system, and NAND gate design with layout and sense amplifier, and domino logic AUI 221 projects, and RIX5 processor I have also designed in RTL, and currently I am doing course in SystemVerilog UVM, and making my profile in digital verification.
Mhm.
I'm also studying Perl and TCL like script, and
Mhm.
that's it. And I'm doing also AMBA protocol, and doing advanced embedded logic design course from my institute.
Okay, fine.
Thank you.
So just tell me the about the ASIC design flow. Just give me the rough idea about ASIC design. What are the
Uh,
steps?
RTL to GDS flow. For RTL, first we create RTL in Verilog language, or System Verilog language, and after that we write test bench, and check the coverage in various tool like Janus or covered, and then we synthesized the RTL code, and then after that we check functional coverage and branch coverage, everything. After that we check after that we did equivalence checking in conformal tool in Cadence, and after that we did DFT, and in DFT and STA we checked STA in different stages, like after DFT or after functional coverage, after everything. And after DFT and scan chain insertion, we did PD. For PD, first we did for planning, and after that power planning and chip design, where we create and block macros with all guidance. And after and we did PD in Tempest tool, and after that we did uh, clock tree synthesis, and uh, and after that also we check STA for checking setup violation and hold violation. And after that we did detailed routing and global routing, and lastly we did DRC and LVS.
Okay. Some of the steps are like mismatching, so you can just cross check it once. Fine. Cross check
Okay.
it once. Tell me the difference between FPGA and ASIC.
FPGA is field programming uh, gate array based program. Here we designed RTL, and we tested in hardware. And ASIC
Okay.
is before tape out. We uh, we create a GDS file through tools and steps like this.
I am asking what is the difference between FPGA and ASIC?
In FPGA, we used Verilog RTL, and tested in a hardware system.
Okay, just cross check this question. Fine, this is not correct.
Okay.
Okay, what is the process? Sorry, Oh, tell me about setup time and hold time in STA.
Setup time is time violation. Uh, be, uh, the data should be present before the clock has arrived, and hold time is the data should be stable after the clock age has come.
Okay, make the diagram also in the exam. Fine, make the in the proper interview. Make the
Yes.
diagram also and with the equation also. Fine.
Yes.
Uh, okay, in the fabrication we prefer the NAND gate over NOR gate, right? You know about this thing?
Yes.
So why you prefer this thing? Like why NOR NAND
But,
gate?
NAND and NOR basically firstly universal gate and NAND and NOR.
Yeah. So why you prefer?
Density
Why
will be
you?
more and delay will less for NAND and NOR.
Okay.
And
Okay.
for
Just
CMOS design, we use NAND and NOR gate.
no,
Through
we prefer the NAND gate or NOR gate in fabrication, right? I am asking why we prefer NAND gate instead of NOR gate. We can use both.
because electron mobility is higher and NAND is basically electron control.
Okay, just cross check it this also. It should be related to the area. Okay. Uh, Tell me the difference between combination and sequential circuits.
Combination circuit basically based on it's not that does not depend on the memory, and sequential circuit has a memory component in this, and combination circuit like mux decoder encoder, and it's made of and sequential circuit is like a flip-flop register which based on present state and as well as past states and future state. Basically it has a memory component.
Okay, fine, fine. Give the example also, right? Give the example also.
Yes. Sequential circuit like latch and flip-flop, and combinational circuits are like mux and decoder encoder.
Okay, which is more faster, latch or flip-flop?
Latch is more faster.
Okay, okay. Yeah. Tell me about the noise margin. What is noise margin?
Noise margin is basically measured that how much noise can accept the circuit.
Okay, fine, fine. You know about depletion region? You know about depletion region in
Yes,
analog?
depletion
Yeah, tell me
region.
about the depletion region.
Depletion region is occurred in transistor when pinch off occurred like after when VT is reached in gate and electron and hole pairing is generated, then depletion region occur basically.
Okay. You have to make the diagram also, right? In
Yes.
the exam.
Yes.
Okay. What do you mean by body effect? You know what body effect in analog?
Body effect when body like transistor is MOSFET is four terminal device, gate, source, drain and body. When body voltage is less than gate voltage and basically it is negative it has negative polarity, then VT or threshold voltage is increased. This is called body effect.
Okay, fine. Uh, you can tell me about the clock screw. What is clock screw? You know what?
Clocks actually when capture path delay or launch path delay create clock skew. When capture path late early, sorry, capture path will be late, then skew is positive, and launch path will be late, then skew is negative. Basically it is variation from actual time from yeah uh, yeah, left or right. Clock edge. Difference of clock edge from actual timing.
Mhm. Okay,
It's an uncertainty.
okay, fine. You know what ATPG and DFT? You know what ATPG and
Yes,
DFT?
sir. Automatic test generation pattern, and DFT, which is which insert scan chain to check the flip flop in design or
Mhm.
SoC.
Okay. Oh, so DFT and ATPG is same or like DFT is a part of ATPG, but
ATPG is a part of DFT.
okay, fine. Uh, there are two type of routing you said, right? Detail and global routing. So tell me the difference between both the routings.
In detail routing we in global routing we create the clock path and we create the metal layer. We plan the where will be the metal layer and how it flow, how clock metal, how metal layer will designed for clock and for any connection for power or any pin to source, like that. In global routing, in detail routing, we actually route this thing.
Okay, okay. Make the diagram also fine in the exam. Yeah. Can you tell me the difference between standard cell and gate array?
Standard
Gate
cell
array,
and gate array.
gate array. Yeah.
Standard cell like um, NAND, NOR, and basic cell structure, and gate array. Um,
It is array of gate.
Array of gate, combination of gate.
Just check it once, fine. Check it once.
Okay.
Okay. Mm. Difference between flip flop and latch up.
Latch
Sorry,
up.
latch and flip flop. Sorry,
Uh,
latch. Latch.
Latch. Flip flop is edge trigger. Latch is um, level trigger, and flip flop is slower than latch, and uh, flip flop. Both are memory element, sequential element. Uh, Flip flop is used for counter and
Mhm.
shift register and finite state machine.
Why we generally use the flip flop instead of latch in our circuits?
Uh, why you use flip flop over latch?
Yeah, generally in our circuits.
Mm, Flip flop over latch. Because it is edge trigger circuit and it is beneficial. Level trigger we should on for much time, and power
Just
consumption is okay.
cross check this question also. Can you tell me the example, one application of latch where we are using latch?
For making flip flop.
Okay, okay. Application of buffer. Tell me the application of buffer.
Yeah, we insert buffer for reduce setup violation sometimes.
Okay, yeah. Tell me two ways to remove the setup and hold violations.
We
Two
can
different ways.
upsize the cell to reduce setup violation. We pulling the launch path and pushing the capture path. We can reduce setup violation, and and we can change LVT cell to HVT to reduce setup violation. And for hold violation, we can uh, downsize the cell, and pushing the launch path and pulling the capture path, also we can reduce hold violation.
Okay. You know about pipelining in computer architecture, pipelining
Yes.
concept.
Yes.
You tell me about the pipelining and what are the five stages, five stages also.
uh, in pipelining we basically did that um, we multiple instruction we can execute in multiple clock cycle. Basically CPI, we need to check that CPI should be one or close to one. I mean, one instruction in one clock cycle we want to execute, and the five stages are fetching, decoding, execution, and memory and write back.
Okay, okay. Five stages. What are the
Yes.
five stages?
In fetching we fetch the instruction. Decoding, we decode the instruction, what should we do. Execution, we execute the ALU operation or register operation, what we need to do. And in memory operation, that we store the value of executing after execution in a proper address. And in write back operation, we write back the value.
Okay, fine, fine. Okay. Tell me the difference between RIX and SIX.
RIX,
RIS, CIS.
RISC consists both are ISA, and RISC is less complex than CISC. RISC has multiple uh, instruction. Both can be multiple vary instruction, but RISC is less complex than 6, and timing of RISC is less than 6. Timing of 6 is more. Complexity is less in 6 processor, and it has 5 stage, and 6 has more stages.
Addressing mode registers.
That is,
Go check it once. You told me like you have done the project on Trix 5. Tell me about the projects, what you have done there.
I have done the RTL code in Verilog for all the 5 stages, and we implement the instruction like branch instruction. And for branch instruction, we create a FSM, like taken and strongly taken and weakly taken and taken 4 branch instruction we have produced. And after that, we also implement bypassing and stalling instruction. We also implement load NOC and store NOC instruction in that, and ALU instruction.
Okay. Then why we are using RIX process? Why? What is the objective of making RIX process?
RIX processor basically, RIX also supports pipeline and can execute basic instruction, but 6 is more 6 efficiency is more than RISC. 6 can execute more complex instruction.
Okay. Okay. Mm. Uh, just wait. You know about Verilog, right? Tell me the difference between Verilog and VSDL.
Verilog is VHDL basically high level language. Verilog is using for RTL generation. Verilog basically machine level language, and VHDL high level language.
Okay. Oh, you know what is strong type and weak type?
Sorry?
A strong type, which is a strong type language, and which is weak type language.
No, sir.
Okay, no problem. Just check it once. Tell me the difference between inter and intra statement in Verilog delay statements.
क्या?
Inter and intra statement delay. You know about inter and intra?
No, sir.
It's very important question. Just check it once. Inter and intra delay statements. Okay. Tell me the difference between edge and wire.
Rage and where. Rage basically used in procedural block, and for actually parallel execution, and where is basically used in combinational block or sequential execution.
Okay.
Like for assign we can use where, and for always block we can use rage.
Okay. Okay. Tell me the difference between blocking and non-blocking. Verilog.
Blocking statement is a sequential statement, and non-blocking statement is a parallel statement. Blocking statement is used for assign, and non-blocking statement can be used for like always block. Blocking statement is for used for combination, and non-blocking statement is used for a sequential circuit.
In the exam, just give an example also, right? With some digit also, so that it gives the more idea to the interview, right?
Okay.
Just take the pen and copy in the next interview also, whenever you will give with us, so that we can give it nicely. You know what double equals to and triple equals to? What is it?
Yes, double equals to actually operates only 0 with generate only 0 or 1 output, and triple equals can consider the x and z value also, with 0 and 1 x and z.
Okay, fine. Okay. You know about dollar display, dollar monitor, and dollar stop?
Yes, sir.
Tell me the
Dollar
difference between-
display. Huh?
Tell me the difference between all these three.
Dollar display display the executed value. Dollar monitor display the executed value with proper timing, and for every change of value it display shows value. Dollar monitor, and dollar strobe shows the value after all the execution have completed.
Okay. In the exam, just take the example also of this, right? So that you can give the more better idea. Or otherwise, interview will automatically give you the digits and he will ask output, right?
Okay.
Okay. You know about sensitivity list, right? So tell me what is sensitivity list in the value.
Sensitivity, like for always block, we need some sensitivity that where when data will change or when always block should be executed, like at always at the start, when anything in change in always block, the operation will be done. When always at the rest pauses, then when the clock as it pauses, then positive edge, then the execution will be done. And when always at the rate neg edge, then when the clock is in negative edge, then the execution will be done.
Hmm. Okay. Okay. Hmm. Now coming to the next puzzle. You know about the difference between transport and inertial delay?
Transport and inertial delay. So I can't remember it now.
No
Uh,
problem. No. Okay. Hmm. Oh, why we use SystemVerilog? Oh, tell me the
uh,
advantage
this
why we are using SystemVerilog over Verilog.
supports ops concept, which and it has code reusability, and it gives code coverage better, and it actually basically used in verification model, and based on SystemVerilog we can operate UVM.
Mm-hmm. So why we use UVM if we are using SystemVerilog?
There are so many verification technique, but we used UVM, which is universal verification technique, and it allows all the ops concept on SystemVerilog, and it also gave a proper functional coverage and functional verification also, and
Okay.
every
Yeah, just cross check it once. Right? Okay. So tell me what is fork and join? You know what fork join any, fork join none?
Yes,
Yeah,
yes.
tell me.
Fork and join basically a thread, where fork join is basically when all the fork will executed, then uh, then the execution will end. And when all the thread is execution, then the execution will end. Fork join. And fork join any when any thread of the fork is executed, then execution will end. And fork join none when any of before any execution of any thread of fork, it will end. The block will end.
Give the example also.
Okay.
Tell me about dynamic and associative array. Difference between
Dynamic
dynamic and associative.
dynamic array, we can change the value of array uh, through the code, or dynamically we can change the value of array or number of block of the array. And associative array is basically a static array. We predefine, we need to predefine it.
Okay, fine. You know about RAND and RANDC and trends
Uh,
C.
yes, sir. REND basically generate random variable with repetitive mode, and not it is not unique. And RENDC generates random value, but it generates only unique. I mean, it's repeat. Before its repetitive mode, it only produce unique value.
Difference between module and program log.
Module, uh, we can create module multiple time, and we can create program once, and we need to use this program repeatedly.
Okay. Tell me about inheritance concept.
Sorry. Inheritance concept.
Inheritance.
Inheritance basically inherit the property of a parent class to its child class. Means the property program everything of the parent class automatically inherits in his child class, and it inherits by one keyword, that is extends.
Okay. Okay. Just take the pen and copy also in the exam and tell the proper
Okay.
diagram and all, right?
Yes.
So they will able to catch it, right? Because
Yes.
if you just tell one definition, that is not enough, right?
Yes, sir.
Uh, Tell me the difference between function and code coverage.
Function and code coverage. Functional coverage is that from the RTL we can generate that the function which we want to produce, that is intact, and code coverage is that the every line of the code is covered in through the verification process. Like for but if we write a test bench, then we write test bench in that a manner that every line or every instruction of the code should be covered in that test bench. This is code coverage.
Okay. Okay. So code coverage should be 100% or line cover like code coverage or functional coverage should be 100%. Which should be 100%?
Code coverage should be 100%. Then
Not
functional
both.
coverage. Coverage automatically be 100% when code coverage is 100%, or it execute properly and the logic of the code is right.
Okay. Okay. Tell me the difference between new semicolon and new bracket.
A new bracket create objects,
Okay.
and
And
new
you
semicolon.
not semicolon, it's corner brackets and square bracket.
Uh, this is array.
Array. Okay. Just check it once.
Mhm.
Okay. Mm, Deep copy and shallow copy.
Deep
Different.
copy basically copy all the object with reference and value, and shallow copy only copy the reference of the object.
Okay. Take the example also. Fine.
Okay.
Difference between packed array and packed array. Packed array
Uh,
and packed array.
Packed array is basically the array where values or number of block should be cleared at the beginning, after the mentioning the variable. And unpacked array, we need to define the block number of blocks before mentioning the variable.
You know about
And
constraints?
uh,
You know
constraint,
about
yeah.
constraint?
A constraint basically used for object for define the object, like a parameterized concept, non-parameterized concept. Constraint basically define what type of the object is this and how it will work out, like that.
You
Oops,
know
sorry.
about inline constraints?
Inline
What
constraint.
are the different type of constraints? What are the different type of constraints? What are
Parameterized
the
constraint, when we invoke a uh, object, by default a default constraint is created, and when we mention a constraint, we can give a parameter, or uh, we can null the parameter also, like
Mhm.
parameterized concept and non-parameterized concept. If we give value in time of creation of the object, then it will be inline constraint.
Okay. You know about cross coverage? You know about cross coverage?
Cross coverage.
Uh,
And also,
okay, fine. Can we start with UVM also? Can we ask some questions from UVM?
yes, sir.
Okay. Why we are using UVM if we have the system?
UVM basically is a process of verification,
Hmm.
universal verification process.
Hmm.
After OVM, open verification process, we introduced UVM because UVM has more code usability, function and structure, and it supports OOPS also.
Hmm. Hmm. Okay, fine. You know about super keyword? Super keyword.
Super keyword basically used in inheritance. Basically, it's a keyword that define the parent class.
Okay. So according to you, UVM is independent of SystemVerilog or it is dependent on SystemVerilog?
Dependent on SystemVerilog.
How it is dependent?
Uh, for writing the code, for generating the test bench
Okay.
or everything, we use SystemVerilog.
Okay. Tell me the difference between new bracket and create. New and create.
New and
New and create. New bracket and create.
new and create.
Okay,
New
fine. Okay, fine, fine. You know what TLM port, TLM port, TLM
yes,
and analysis port,
transistor level modeling port, and I have
analysis port.
uh,
Okay, fine.
um,
Hmm. What is different between copy and clone?
copy and clone. Clone means the whole structure clone. Copy, and copy means some part of copies of some part.
What is different between universal slash uh, virtual slash sequential, and what is difference between UVM slash sequential? Sorry, sequential. So एक में virtual है, एक में virtual नहीं है basically. So if we're writing the virtual, what do you go into it? What is the specification of that? Like, what do you mean by that? नहीं पता.
Nahin.
You know what virtual interface?
Yes, I have read, but actually I forgot.
Okay. You know about trail model?
I have read.
Okay. कुछ पता है rail model का? At least full form.
Huh?
At least you know the full form. You know about full form of rail.
भूल गई हूँ
Okay.
मैं.
कोई नहीं. Hmm.
UVM बेसिक्स ही पढ़ी हूँ अभी तक.
Okay, fine. You know about phases in UVM?
हम्म.
Phases नहीं पता. Okay. UVM नहीं आता.
Phases, build phase, run phase, that phases, na? Yeah,
9 phases are. Yeah.
yeah.
Okay.
Build phase uh, where test bench is built, and run phase where execution is there, and like monitor, agent, scoreboard, all are created some phases.
Mhm. Okay. Okay, fine. So tell me something about microprocessor. Like microprocessor पढ़ा है आपने? 8085, 8086.
माइक्रो प्रोसेसर तो नहीं पढ़ी हूँ, पर अभी मेरा एएलडी चल रहा है, जैसे एडवांस माइक्रो वो वाला, तो उसमें एफपीजीए से काम कर रही हूँ. जेड बोर्ड एंड जाइबो बोर्ड एंड प्रोटोकॉल्स एएक्सआई एचपी एपी.
You have used FPGA board in the college? FPGA board use किया है college में?
Yes sir, जेड बोर्ड.
Yeah. Can you tell me the architecture of what are the component in an FPGA board, and what are the which FPGA board you are using? Which company?
जेड बोर्ड एंड
Like Xilinx or
जाइलिंग
Keysight,
जाइलिंग जेड बोर्ड.
Xilinx. Okay. Okay. Um, okay, fine. So tell me architecture. What are the components in FPGA?
Basically SoC and in memory microcontroller is there, and some ports, input output ports, peripheral PSPL interfaces, general interfaces,
Mm.
clocks,
Uh,
timer.
Lookup tables. You know about
Yeah,
lookup table?
yeah, lookup table.
Okay. Okay, fine. Mm. So which is the strongest part you have in like a VLSI में सबसे ज़्यादा strongest कौन सा area आपका?
Strongest digital design. After that,
Digital.
I have get some skill in analog design also. Like I have made layout in Virtuoso Cadence, and I have cleared all DRC, LVS, and post layout extraction, everything, and post
Okay.
layout simulation I have also done. I'm comfortable with
Okay.
both digital and analog, and memory
Okay.
too. I have done project in six modified 60 SRAM and sense
You have done
amplifier.
the FIFO project also? You have done the FIFO project, right?
A FIFO project I have not done. I know the code of FIFO in art Verilog, and I have done something in verification of FIFO, like
Okay.
methodology
FIFO
of
depth calculation. FIFO depth calculation.
FIFO. Yeah, n log n minus one.
There are different cases in FIFO depth. You know what all the different cases?
Yes, sir.
Like 7
Like
and 10.
a full or empty cases.
नहीं 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 वो different है. There is one PDF, made easy PDF. Okay, no problem. There it is in the app. You can go through it.
Okay.
P4 depth calculation, that is important concept. You know what difference between sequential and is sorry this synchronous is asynchronous FIFO.
Yes, where read data and write data signal is different. Then it is called
Mm.
asynchronous FIFO. When read and write both have done through one signal, it is synchronous FIFO.
Mm. Okay. Just know more about it, right? You know about meta stability?
Yes, sir. When flip flop at is in this stage where zero, it has no permanent value 0 or 1. It is changing. Then it is metastable state. Basically, it is created by clock domain crossing when frequency or timing is valid in between flip flop when they are changing from one clock domain to another clock domain.
Mhm. You know what CDC?
CGC,
CDC? CDC, CDC.
clock domain
Clock
crossing.
domain. Yeah.
Yeah.
So tell me.
Clock domain crossing basically creates when signal from one clock to another clock is passing and frequency or timing analysis is violate. Then it is happen and flip flop goes to the metastable state where it has no defined state, and it may be 1 or it may be 0.
Okay. Okay. Just know more about it. Like there are different techniques also in CDC,
Yes,
right?
like handshaking technique and FIFO technique and multiple flip flop technique.
Okay. You know about synchronous reset and asynchronous reset?
Yes, I know.
Okay. ये क्या होता है? Tell me something about it.
Synchronous reset. Basically, when reset is operated by one clock only, then synchronous reset and multiple clock asynchronous reset, something like that. Okay.
There is a difference between in the code also, right? In the
Yes,
sensitivity list.
yes, yes, yes. When we create synchronous reset is when we design a flip flop, then a synchronous for synchronous flip flop reset in not mentioned in sensitivity, and for asynchronous flip flop reset should be mentioned in sensitivity, like in always block.
Okay. You know what PLL? You know what PLL?
Phase loop locked loop. I know only the full form. I I
Mhm.
have I know the basic structure like
Hmm. Where you
comparator.
have used it? Where you have used it? कौन से
I
subject में
have
पढ़ा है?
not used it. I have not used it. I just read about that in analog circuit.
Mhm. Analog circuit. Okay, fine. Can we ask some question from analog also?
Yes, sir.
Okay, tell me about current mirror.
Current mirror basically a circuit which uh, when we generate a reference current and through the transistor it can copy the reference current to that branch, and it depends on the transistor sizing, I mean ratio of W by L, width by length value. Like R I reference by I generate equals to W by L of reference by W by L of generate.
You know about the diagram also? Like current mirror, you can
Yes.
make the diagram also.
Yes,
Okay.
I know.
Okay. Tell me the op-amp. What is op-amp and what do you mean by op-amp?
Op-amp,
How do you do
op-amp basically a differential circuit,
it?
differential amplifier circuit. It based on two inverting and non-inverting port, and the difference between these two ports is infinite resistance, and generate a differential output. Through op-amp we can create a integrator differentiator circuit like
What is
that.
the advantage of current mirror circuit? You know about
uh,
any advantage of current?
Current mirror circuit, एक minute. Current mirror, constant current, it provides constant current.
Constant current, but it is using less components also. Circuit is simple.
Yes,
Can
less
just check
transistor
it
is
for
used.
these questions also.
Yes.
Uh, Five characteristic of ideal op-amp.
Five characteristics, like
Ideal op-amp.
uh, input in resistance is infinite, and
Mhm.
CMR is infinite,
Mhm.
uh, and differential amplifier is used, and mm,
See, these are very basic question I'm asking from the analog, right? We have
uh,
not all very depth, right? So at
yes,
least even if you are going for digital interview, at least go through the analog basics, right?
okay.
At least the short notes you can go handwritten notes and all.
Mhm.
You know what positive and negative feedback?
Yes, positive and negative
What
feedback.
is different in between?
Not when feedback is taken from non-inverting uh, port, then it is positive, negative feedback, and from inverting port, that is then it is positive feedback.
Mhm. Which is beneficial according to you? Which is more benefit?
Negative feedback is more beneficial. It reduces the error,
Okay. And stability is which have the
and
more stable?
stability is more in negative feedback.
Okay. Why then? Where we use the positive feedback?
Positive feedback sometimes in addition.
No, there is one application of positive feedback also, right?
Um,
Okay, just check it once. No problem. What do you mean by CMRR, common mode rejection ratio?
Actually, it is differential mode, different common mode gain and differential mode gain ratio of these two is CMRR, common mode rejection ratio, and that an op-amp can handle up to which noise level. It's basically uh, measurement of this.
Okay, just cross check all these things.
Mm.
So can we ask from digital electronics some question from digital?
Yes, sir.
Why we use gray code, gray codes?
Gray code is a self-complementary code,
Hmm.
and it reduce it reduce the number of transaction actually. So we use gray code.
Okay. You know about static hazards and dynamic hazards?
Static hazard and dynamic hazard. Uh, I knew it, just I forgot. I know hazard in CA, like in cache hazard. I
Okay,
sorry in
okay, just wait.
hazard in pipeline. I am remember.
Just wait for 1 minute. My laptop is closed. Or can we end the session? Can we end the session?
Yes, no problem. Any feedback for me?
Yeah, just improve like some of the things you have to improve.
Mm.
Just wait. तो एक तो आपको like yeah, this is audible. So I will say like improve some of the things like you know what super you are telling me the definitions of the basic thing, right? But in the interview you have to write the pen and paper and tell everything. Whether it is offline interview or online interview, you have to ready just tell everything with the example, with the numerical, with the circuits, with the diagram, so that
Mm.
they will be able to understand that you know it properly. If you are telling
Mm.
setup time whole time the definition, it is not good, right? You have to tell
Mm.
in the depth, right? So
Okay.
just try to tell, and these are some basic questions only that I'm telling you, right?
Mm. Mm.
So if you able to tell the basics in very strong manner, you can compensate the loss of the difficult question which you don't know, right? So that is a
Mm.
thing. So just improve this thing. Fine. Okay then, fine. Okay, fine,
Mm.
fine. Thank you so much.
Mm.
Thank you.
Thank you. Thank you.